All right, today we're going to talk about standard form. We've been talking about quadratics and the three different forms that we have: standard form, vertex form, and intercept form. But today we're going to focus in on standard form. So let's go to work. What does standard form mean? Essentially, standard form means you get your terms lined up, make them high to low. Look for a GCF. That's something everyone should know. We got two terms and a minus in the middle. Now we cooking, like cooking bacon on a griddle. Remember, when we're talking about terms lined up high to low, we are talking about the exponents. We are talking about the exponents lined up from high to low. Okay, so this is not new. We've been doing this for a while now. I want to talk about the individual parts being the A, the B, and the C. Okay, let's start at the end, or let's start with the C. What does C stand for? Stands for the constant. The constant. Now, what is a constant? Constant is a number by itself. But as we've been talking about these polynomials, we said, hey, what's a polynomial? A polynomial has to have a variable to a whole number degree. And we even had a discussion at one time and said, hey, is 7 a polynomial? And somebody's first reaction was, well, no, it doesn't have a variable. Then we said, well, wait a minute. Couldn't we write 7 times x to the 0 power? Because anything to the 0 power is 1, so x to the 0 power would be 1, right? And 7 times 1 would be 7. So we said, hey, well, wait a minute. I guess 7, or just a number or a constant by itself, is a polynomial, isn't it? It's a polynomial to the 0 degree, okay? So we did realize that a constant, even though it's just a number by itself, is part of a polynomial. Well, that's cool. But what I want you to get today, and this might be the new thing for you, is that a constant is also, and this is important, the y-intercept. We are going to begin graphing these quadratics today. And the first thing I want you to get is that the constant is also the y-intercept. Just as a refresher, the y-intercept is where the graph crosses the y-axis, right? And here's the cool thing. Anytime, any type of polynomial function, any type of graph that we're going to do, if it's in standard form, the constant is always your y-intercept. So you could be taking the ACT or the SAT or something and have a multiple choice question and say, hey, graph this polynomial. And it could be some crazy one to the 7th degree. And you can look at the constant and see, hey, the constant is 3. So it's got to cross the y-axis at 3, right? And look down at those multiple choice and only one of them crosses at 3. It has to be that one. That's how important this is, okay? The constant is always your y-intercept, okay? Now, let's jump to the front and let's talk about the degree. We've already talked about the degree, and we've done that a lot, okay? Remember, the degree does two things. First, it names it. It names the polynomial, right? And then it also talks about its end behavior. I'm going to remind you of the end behavior. We have talked about this in the past, but I'm going to remind you of it. So first, something to the first degree was called linear, right? Okay, something called linear. And that just basically is a straight line going up or down, yes? Then something to the second degree is called quadratic. Why is it called quadratic? Doesn't quad mean 4? Well, yeah, quad does mean 4, but remember, something to the second power has the nickname squared, and a square has 4 sides. It's that nickname of squared that caused these to be called quadrilaterals, or excuse me, quadratics, okay? And the quadratic has a U-shaped graph, right? It could be open up or open down. Hold on a second. Let me Make my little f of x here a little bit smaller. And move it over a little bit more so I have more room to work here. Okay. All right, something to the third degree was called cubic. Okay, called cubic. And it had a little squiggly line. Ooh, that was ugly. I don't know, something like that. All right. Something to the fourth degree was called quartic. Looks something like that. Something to the fifth degree. Anybody? Quintic. Good. Quintic. Its graph would look like, I don't know, something like that. Something to the sixth degree. I'm going to stop there. Would look like that. We've already taken all of that information in notes previously this year. So I just want to give you a refresher. The degree names it and tells us its end behavior. Remember, if it's odd, it goes in opposite directions. Remember? And if it's even, the ends go together. They either open up or open down. Right? Look, 2, 4, 6, 8 all have ends going together. 1, 3, 5, 9 all have ends being John Travolta going in opposite directions. Staying alive, staying alive. All right. Okay. Now there's your refresher about the degree. That's stuff that we already know about the degree of the polynomial. Now let's talk about the leading coefficient. The leading coefficient. Because the leading coefficient tells us more about that graph. For example, we are going to only be dealing with quadratics, so that means U-shaped graphs, okay? So if my leading coefficient is positive, my parabola is going to open up. If my leading coefficient is negative, what do you think is going to happen to my parabola? It would open down. That's right. So if it opens up, it's positive. If it opens down, it's negative. Something else interesting happens with that leading coefficient. If that leading coefficient is greater than 1, as in like, 2, 3, 4, 5, etc., that parabola will get skinny. If it's less than 1, but not less than 1, but greater than 0, it'll get fat. In other words, if it's a fraction, it'll get fat. Okay? I'll explain what I mean by that coming up. Okay? The last thing I want to talk about is this stuff in the middle. Okay? This thing in the middle, and I went to a different color here to hopefully make sure it jumps off the page at you. And this is, mathematically speaking, called the linear term. Okay? It is definitely, or mathematically speaking, called the linear term. Anybody tell me why it's the linear term? Because it's like to the first degree. Absolutely. That's exactly why it's the linear term. Okay? Remember, the degree names it. So that's the linear term. But I affectionately like to call it the junk in the trunk. Not trunt. Okay, because it's that junk. You see over here on all these ones, this stuff in the middle, where I got it looking all crazy. It's the junk in the middle that causes those things and tells us where all this stuff in the middle is, okay? And that stuff you'll spend a lot of time studying in Algebra 2, pre-calculus, and so on and so forth. It's some difficult stuff, okay? So we're going to start by dealing with ones that have no junk, okay? And it's going to be important. All right? Everybody looking good? All right. Let's move on. And let's start with the vertex, okay? Because we've already said that the constant tells us where the parabola or where the graph crosses the y-axis. If there's no junk, where it crosses is also the vertex. Well, what's the vertex? Let's tell you. The vertex has two definitions. Let me give you both. The vertex of a parabola is the highest or lowest point on the parabola help if I could spell parabola. For example, if it opens down, it would be the lowest point. If it opens up, if it opens up, it would be the lowest point. If it opens down, it would be the highest point. Okay, that's why I say highest or lowest. The second definition is the vertex is the point where the parabola changes direction. For example, if I'm drawing this parabola and I'm going down, 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 up, 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 up. That point right there where it changed direction is called the vertex. Or if I'm drawing one like this that's going up, 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 and then down, 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 down. That point where it changes direction is called the vertex. Now, something else happens at the vertex, and that vertex is going to become important to us. And the other thing that happens is that we have an axis of symmetry that goes through the vertex. Axis of symmetry. What is an axis of symmetry? It's that line, that imaginary line, that where if you folded over the graph over that line, the line would end up lying right on top of itself. Symmetry means the same, right, on both sides. That becomes very important to us when we're dealing with parabolas. So like this point that's 1 unit away on one side should be 1 unit away on the other side, and so on and so forth. Okay? So the vertex is the highest or lowest point of the parabola, or the point where the parabola changes direction, and the axis of symmetry will go through the vertex. Cool? All right. So we're getting lots of good stuff here. And then we want to make sure that we realize that if there's no junk or no linear term, the vertex is going to be on the y-axis. What you're going to find is these are very, very easy to graph if there's no junk. Okay? For example, this one right here, notice that it has no junk. Yes? No linear term. Therefore, we would graph it, and its y-intercept of 3 would also be its vertex. All right? Let's do a few. Sorry, I went the wrong way. There we go. Let's do a few. Oh, lovely. I knew I forgot something. Forgot to erase these before you all got in here. But it's all right. Done. Okay, let's look at this very first one, number 1. Okay. What is the constant? Well, there isn't one. There's no constant there. Therefore, it would really be plus 0, right? So where does the line cross the y-axis? At 0. Okay. But since there's no junk either, that y-intercept is also now my vertex. Okay. Now we look at the leading coefficient. What is the leading coefficient? It is 1. Now here's the really cool thing about the leading coefficient in parabolas. The leading coefficient will also tell you where your first point on either side of the vertex is, 1 unit away. And we kind of use it like slope. It's not slope, it's kind of like slope. In other words, my leading coefficient is 1, so from that vertex, I can go up 1 and right 1, up 1 and left 1, and there is a rude graph of my parabola. I don't say rude because, it's going to say mean things to you. It's rude because it's really quick and non-precise. Okay. Just as a side note, f of x equals x squared is known as the parent function. Okay. F of x equals x squared is known as the parent function. So let's try another one. Again, looking at number 2, we always start with I like to start with my constant. In this case, my constant again is 0. So I plot that point on the y-axis. You see it's already plotted there. And then I see there's no junk. So since there's no junk, that is also my vertex. Then I finish by looking at my leading coefficient. What's my leading coefficient? -1. So from there, I'm going to go down 1, right 1, down 1, left 1. There is my parabola. Cool? Number 3. What is my constant? And everybody said 2. So it's going to cross at 2. Since there's no junk, not only is that my y-intercept, but it's also my vertex. Now I go to my leading coefficient, which is 1, and I'm going to go up 1, over 1, up 1, over 1. Think you can handle that? All right. Try number 4. Try number 4. Mr. Green, what's my constant? Nope. Dordo, what's my constant? -3. So I put a point at -3 on the y-axis. Is there any junk? No junk. So that is not only my y-intercept, but it is also my vertex. Okay. Tomorrow, I'm going to deal with ones that have junk in it. And you're going to see that the junk causes a lot more that we have to do. We have a formula, -b over 2a. We got to plug values into those formula. Then we got to take that value and plug it into for x in the whole polynomial equation. We got to solve it. That gives us our y so we can find our vertex. A lot to do. But here, no junk makes it easy. Now, what's my leading coefficient? The cycle? So it's -1. So from that vertex, I'll go down 1, right 1, down 1, left 1. Cool. Now, we've said over and over again that, or I've said a couple times that this leading coefficient kind of acts like a slope, but it's not actually the slope. And here's how I'm going to, in these next couple questions, I'm going to show you how it's not like slope. Okay. Starting with number 5 here. Constant is 0. Everybody see it? So it's going to cross there at 0. There is no junk. Therefore, it's my vertex. My leading coefficient is 2. So from that point, I'm going to go up 2 over 1. Up 2 over 1. Boy, that sure looks like slope, doesn't it? Yes? And as long as your number is greater than 1, it's kind of like slope. But when you see it, that leading coefficient being a fraction, here's where it's not like slope. Okay. Again, my constant is 0. So that's my y-intercept. No junk, so it's my vertex. My leading coefficient is 1/2. And if it was slope, you would think I'd go up 1 over 2. But that's not what it is. This leading coefficient tells me how much it goes up. It's going to go up 1/2 and over 1. So up 1/2 and over 1. You see the difference between this leading coefficient and slope. Yes? And there, notice how it got a little bit flatter or fatter. Okay. Let's try number 7. My constant or y-intercept is 1. No junk, therefore it's also my vertex. Leading coefficient is 3, so I'm going to go up 3, 1, 2, 3, over 1. Up 3, over 1. Look how tall and skinny this parabola is. Remember, the larger your number gets, greater than 1, the more skinny your parabola will be. Number 8, my y-intercept is -2. That's my constant. There is no junk, therefore that makes that my vertex. And my leading coefficient is 1/4. So I'm going to go up 1/4 and over 1. Up 1/4 and over 1. Here's another reason why this is called a rude graph, because I'm estimating 1/4 there, aren't I? Okay, and that's okay for most of what we're doing. I mean, if you're needing exact values, obviously we have calculators and different ways to get exact values even from a graph. Okay, think you can handle that? Okay, here's your homework tonight. Okay, I want you to, 1, copy down questions 9 and 10, and then I want you to graph those. Just graphing numbers 9 and 10. Then, once you get home or at some point today, I want you to take your notes and I want you to rewrite them neatly. This is a study technique. This is important. Don't just let this one fly over your head like, oh, this doesn't matter. It does. I want you to rewrite your notes neatly. And finally, study the definition, forms, and formula from the quiz that we had today, because you will have it again tomorrow. Questions?
Do you want us to rewrite like all of the problems still, or just
No, just the notes part. Just the notes part. Okay, good question. All right, have a great day.